All right, well, let's go ahead and get started. I'd like to welcome everyone to this afternoon's webinar. My name is Kevin Mickey. I am a former president of the Geospatial Professional Network, currently co-chair the GPN's Community Resilience Work Group, and also involved in a number of other areas, as many of my colleagues in the organization are. The Geospatial Professional Network, if you're unfamiliar with it, is a vibrant community. It unites the emerging as well as experienced GIS professionals through top-down education, through networking, and many, many opportunities for career development. GPN is committed to upholding ethical standards, empowering its members to support other organizations, advance careers, and shape the future of the geospatial profession. There's many different activities that are offered through the GPN. Among the most uh, well received and frequently attended are our leadership academies. We have two offerings coming up. One in New Orleans in the state of Louisiana in early November, and a second GIS Leadership Academy in beautiful Savannah, Georgia in early December. If you're looking to grow your leadership skills, there are very few opportunities that you will find to do so more effectively in a more collaborative environment than the Leadership Academy. So I encourage you take advantage of these opportunities, and if these dates don't work, rest assured more will follow. The GPN has a new learning annex. It's designed to provide you access to previously recorded webinars, certified workshops that have been updated to on-demand courses, conference proceedings, and more. Visit it often because new information is frequently provided. You can also earn certificates of completion to use towards your GISP education points, and you can take the opportunity to learn on your own time. Um, this is a wonderful resource. I hope you do take advantage of it. If you have never attended the GIS Pro Conference, your opportunity is coming up to do so. In October, from the 6th to the 9th, the GIS Pro in the Rockies Conference will take place in Denver, Colorado. This is multiple days of professional presentations, networking opportunities, opportunities for collaboration, opportunities for learning, and rest assured, opportunities to have fun, all in a beautiful location of the country. It will be the best week of the year. Make sure that you show up and don't lose out on the chance to be part of GIS Pro. So, bottom line, the GPN offers you opportunities to stay connected and be part of a growing and important segment of the geospatial professional community. It is my honor to introduce today's speaker, Jinha Young. Jinha is the Associate Professor of Civil and Construction Engineering at Purdue University's Lyell School of Civic and Construction Engineering. Uh, Jinha's expertise extends to many areas, but most profoundly in the area of geomatics engineering, with his research interests covering unmanned aircraft systems uh, high through high throughput phenotyping for agricultural applications, high performance computing for remote sensing applications, multi-source remote sensing data fusion, and web development, in particular using free and open source software. Our topic today will be data to science, a modular open source geospatial data science ecosystem for climate and community resilience. So before I turn this over to Jen Hai, we'll encourage everyone to post questions if you have any in the Q&A, and feel free to comment throughout the session in the chat. Jen Ha, thanks for taking your time to join us today. I'm sure your presentation is going to be very informative and very interesting for everyone that's attending. Over to you.
Thank you very much. Let me share my screen really quick. Second here. So thank you, Kevin, for great introduction. Hello, everyone. My name is Jin Ha-jung. Like Kevin mentioned, I'm a faculty member at Purdue University Law School of Civil and Construction Engineering. And the title is going to be Data Science. I already mentioned this is a modular open source geospatial data science ecosystem that can be utilized in many applications, but I'd like to talk more about climate and community resilience aspect to it. And I also like to acknowledge my co-author of this presentation, Benjamin Hancock. He's essentially the magician behind this the work where he's doing all this development work to be done, and Minyoung Zhang, she's a postdoc research member in my research group, who's contributing greatly to this project as well. So I'd like to start my presentation by sharing the quote that I heard from one of the presentations that I participated in a couple of years ago, which is in a Seeing the Unseen. And I like to pause this in a moment, and I like you to think about when was the last time when you saw something that you never seen before, and that you get very very excited about it. For me, I still remember my first time when I went to Grand Canyon National Park, and I knew it's going to be great because I've seen so many videos and photos online, and I was expecting something great, but I still remember the moment where I approached that the clip, and seeing it for the first time, not by the screen but in person, that in a grand view. That is something I will never forget, and that was the moment where um, it was so great that I will remember my forever the rest of my life. So if you have any moment like this, I'd like to, put that in your head. And I'd like to start my presentation by playing this
Lani,
video
Lani,
together.
come on. Look at mommy. Look at mommy. Ooh, look at I look so cute. Hello, Mama. Can you see? Wow. Lani, look at me.
Dad, she looks like Bubbles off of Trailer Park Boys.
Yeah. Show Daddy. Show Daddy.
But it makes it look sort of special.
Oh, you can see. She's like looking around.
Can you see that?
Lani,
Leave them. Don't touch.
Lani,
You need them on so you can see.
Honey, look at Regan.
Can you
see?
Lani.
Look at Regan.
Great. So I hope you're going to make the same face by end of my presentation, because then I hope that you're going to see something that you've never seen before. So let's move on. So something magical happened about 600 years ago. And in those days, text information was not available to everybody. And the old ways of generating text information is, as you can see from this top left figure, you have to hire somebody who's going to work on, the transcribing whatever information that you like on a paper, which takes a lot of time. And because of the limitation, only small group of people can actually access this text information. On the bottom right is one of the oldest Bible that is known to exist. Is of course, it's very variable, but this kind of information was, very, very limited in a small group of people. But about 600 years ago, like I mentioned earlier, something magical happened. That is the development of Gutenberg's printing press. After this one, now everybody can access this information, very, very easily, because, before you have to spend a lot of time to to generate this text information, but because of this technology, we can mass produce this text information very, very easily at scale. And with additional development associated with this, now we don't need to hire somebody or pay a lot of money to generate this text information at scale. Nowadays we can go to the library can get easily this the book rented out or purchased. You can access this information and very, very quickly. So like this Gutenberg's printing press revolutionized the information, text information greatly about 600 years ago. I like to turn our head to another type of information, which is geospatial data. because this is in a GPN. We always deal with a geospatial data set in this community. So how about the geospatial data? In my mind, we are experiencing something very similar that happened 600 years ago, happening to us right now. Let's look at some of the traditional, remote sensing platform. What I mean by remote sensing platform is any type of platform that generate this, geospatial data product. Let's say, maybe 10, 20 years ago, if you want to generate any types of remote sensing data, you first need to have a platform to carry some sensor up in the sky. It can be airplane, it can be helicopters, it can be high altitude airplane, or if you just go even bigger scale, if you can go to the space shuttles or in a satellite. All these platforms cost you a lot of money to operate. But in order for you to be able to generate this geospatial data product, platform is one thing, but you also need to have a sensor, to be carried by this platform so they can collect some data set. This is an example of aerial metric camera that can be mounted on an airplane that produce beautiful, high resolution, natural color, sometimes a multispectral imagery to be generated from the airplane. And the cost of this sensor can be easily a couple of $1 million in the sensor itself. But when you combine this with a platform to operate, platform to manage, maintenance costs, flight crew, all those kind of stuff, this kind of platform is out of reach for most of folks. So, traditional way of generating geospatial data product has to, used to be like, we have to pay some money for the big surveying firm, then they're going to produce the kind of data set, then you're going to be able to use this kind of data product. But good thing about this, advanced sensor is now it shows us something that we've never seen before. This animation that I'm playing right now is animation of space telescope that is generated by NASA. And I believe this animation is actually indeed an animation that is generated by Space Telescope at the Hubble telescope. And it almost feels like we are actually zooming into certain region indefinitely. And some of these images that you're seeing over here, we cannot see at all from our naked eyes on the ground. But because of this technology, we can see something beautiful out there using this technology. And this is actually images that is produced by Space Telescope Hubbles. And we recently launched a new space telescope called James Webb, and we actually imaged the same location. Now we start to see there are actually a lot more stars than we never seen before. So let me go back. This is images from the Hubble. This is the James Webb. And with this technology, there's a lot of things that we never able to see before, but we can see those kind of information right now. But what about now, this geospatial data, thanks to advance in drone technology, or some we like to call this as unmanned aerial vehicles or unmanned aerial systems. Now, we can actually produce a beautiful data set at the minimal cost with a very small, the crews out there. This is actually the photos that I took a couple of years ago with my research group going out to the field to collect the LiDAR data. And this kind of data now let us to do similar kind of visualization techniques that NASA generated, of course, in a much smaller scale. But this is an example of cornfield in Texas that I took this video. And by flying this drone, getting close to the ground, now we can see a lot of information that was not visible from higher altitude. It can be from the satellite, it can be the airplane, but then now we can zoom into a lot more detail because we can get close to the ground to generate these kind of images. So this drone technology is great because it lets you see things that you're unable to see before. And some of the example that I'm going to show you later, drone will cost you somewhere around $1,000. You can go even to the Walmart or Best Buy to buy drone and generate beautiful high resolution and very precise geospatial data product very, very easily. You don't have to pay tens of, hundreds of thousands of dollars to the serving firm anymore. Of course, the benefit of those, big serving firms is that they can operate in a much larger scale. But if you have a study area that is small enough, then you can actually generate your own data product, very, very easily. But the big problem of this approach is that now you end up generating a lot of data. Then how you're gonna manage this in a data set, that becomes a big, big problem. So Purdue University invested in some seed money to address this problem, where how we can actually manage this big geospatial data produced by essentially you, and that you can make it more easily accessible to you, but share with others, and also doing data analysis using this data product you created. And this is an online platform that I'm going to have a quick demonstration really quick. And we can actually visualize drone imagery that has extreme high resolution at very, very quickly. And we can also do 3D visualization of this data product as well. And I'm going to switch my screen really quick. So this is then a website. This is an open to public. The domain name for this one is ps2.d2s.org. D2S stands for Data Science, and PS2 stands for Plant Science 2.0 Initiative, because Purdue Plant Science 2.0 Initiative provided me a seed funding to get started on this project. So we named it this as a PS2. And by the way, this is an open to public. Anybody can create an account, and you can upload your own data product and doing exactly what I'm showing you over here. For example, if I'd like to go to this Tipitini biodiversity, this is a beautiful place in Ecuador. And we actually, my research group, flew to Ecuador last year to collect this data set. So let me just zoom out a little bit so that you have a better idea. So this is Colombia. Ecuador is located over here. We flew into Quito, then flew into another town here, then took a boat, another bus, another boat, and to get to this part over here. And it took us about 3 days to get there from Chicago. And once you reach this destination, give me a second, let me just reload this page. Then I can just pull up the drone imagery that I showed you, earlier. I start to zoom in, then you will start to see this, beautiful, high resolution rainforest to show up, right away. By the way, this is multispectral data. That's the reason why it looks a little bit different from natural colors. But I will share something else, later that is more, more fun. But like I mentioned earlier, you can also do this in a visualization over here. We can also, give me a second, I forgot to do this. And we can also do LiDAR point cloud visualization as well. So if I just turn this on here, wow, it is crashing. This is the danger of doing a live demonstration. Give me a second. Just go to the LiDAR and the point cloud. Now we can visualize this first in 3D. So you can just zoom in, turn it around, and I can see all those trees in very, very detail. So you can actually access this data very, very easily. So going back to my presentation over here, we developed this platform so that anybody can actually, collect the drone data and process it and make it available for you. But when you create something, it is great that you can enjoy, yourself. Like example that I'm showing over here, I love to listen to music, and I just, occasionally put my headset on, play music loud so that I can focus, and it works great as well. But even more exciting part of enjoying music is when you actually share this music with a lot of people. This is, if you've been to concert, you probably hear, what I'm, mean over here, the enjoying something together, magnify those, joy, a lot more in, exponential in that magnitude. So, we like to be able to see things that you've never seen before, but even more exciting thing is, if you can share things that you can see that were never able to see before with others, that is even better. And I want to just make some analogy of this sharing information with others in the context of movie. This is in a movie theater over there. We all love to go to watch a movie over there. But not long ago, the consuming this kind of video content was not in the form as we do right now. So I want to play a couple of the commercials that I found online about this the video content.
Imagine the perfect video store. It would have a great selection, right? Right! Over 10,000 videos. 3 evening rentals, so no rush, no hassle. Fast checkout. 24-hour quick drop return. Open late every night. Well, the perfect video store
Welcome to Blockbuster Video.
is popping up all over the country. There's one near you.
Blockbuster Video. Wow, what a difference.
It's the 4th of July.
So you probably remember one of these days where you like to watch movie at home. You're gonna go to this in a Blockbuster store and pick up the the videotape, bring it at home, plug into your VHS player, then you watch a movie that way. But after this, the Netflix came along and they did something a lot more advanced than this. So let me play the next commercial.
There's a better way to rent movies. As many as you want for just 20 bucks a month and no late fees. Go to netflix.com, make a list of the movies you want to see, and in about 1 business day, you'll get 3 DVDs. Keep them as long as you want, without late fees. Then when you're done, look, prepaid envelopes. Return one, and they'll send you another movie from your list. It's easy.
Netflix. All the movies you want, 20 bucks a month, and no late fees.
Hey, I still remember those days where I'm paying, Netflix $20 a month, so that I just go to the online website, click, send me those DVDs, then I'll receive those DVDs by mail. So at least I don't have to travel to the store to pick up those, the media anymore. I just, easy and convenient, right? But how do you consume our video content these days? We don't even, check out, those video anymore. Everything is online. Now you just, open up the Netflix app on your smartphone or most of the smart TV at home. You can actually stream this video right away. You don't have to wait until we see this, the media being delivered to your place. And this is how, we all, consume our video content right now. Everything is great. We just take for granted. We all forget about how we used to consume this kind of video content before. And one good example of this video content consumption is YouTube versus DVD. This is a Google Trend search. I just limited the search to be 2004 and 2010ish or 11ish, over here, 2011. And before this golden cross happened, DVD was a lot more being searched on Google, but something happened afterward. There's no way back right now. The reason why I only searched it until 2011 is if you do the Google Trend search right now, you're gonna see barely nothing about DVD because probably nobody knows about it anymore. There is a big trend in video content consumption now. We don't use any physical media anymore. Everything is being streamed. You don't have to even download any file. Everything is instant right away. And if you look at some of the market share study done by this link at the bottom, YouTube is being claimed as market share of 98% in media players and streaming platform. This is so dominant. Probably, I think this is a statistic that I got a couple of years ago. This might be a little bit lower because we have a lot more other media streaming services out there right now. But this still is the great extreme number that YouTube is dominating this the market so much. And this is the guy who has a YouTube channel called the T Series. He has 263 million subscribers. And this is a lot of people, 263 million. And most of the other big legacy media on YouTube channel has a fraction of subscriber to this person, this channel over here. Then now I come to think about who has more power in this new era of video consumption. Legacy media or this guy from YouTube channel. It's not apple to apple comparison, so we cannot say who has more power than the other. But it is amazing that this small group of people, of course, this is one guy that I'm showing this picture, but there's going to be a lot more crew working behind it, behind the scene. But with a lot smaller, the crews than we have now, way to reach out these so many people, then make an impact, out there. So how do we consume our geospatial data right now? And I think the same analogy applies to pretty much all these commercial that I showed earlier. There are certain group of people who still operate in an old blockbuster way, where hey, I like to use some the geospatial data. Hey, I'm gonna stop by my friend's place, borrow X on hard drive, bring in my home, and copy those the data to my computer, bring it back to your the friends. And this is actually one of the way this Indiana statewide LiDAR data was acquired many years ago. And this was actually around 2018, 19-ish kind of way of distributing Indiana statewide LiDAR data, where USGS is going to collect the data, they're going to create a QAQC, then this hard drive is going to ship to the central location, and somebody is going to send an email to this IG group. Hey, we received this LiDAR data. Who need this data? Then somebody raised their hand, and that drive will be shipped to Fort Wayne, for example. And that person is going to ship back to another person. So it's going to keep circling around. This is more like the Netflix version 1.0, version where you don't have to travel to the location, but we're shipping this media using this legacy shipping method, and that's how it works. But these days, we are not consuming this video content anymore in that way, and we should be able to stream this geospatial data to your computing device. Because thanks to this development called cloud optimized data format, now we can actually stream our geospatial data to a computing device. The example that I showed earlier, Ecuador Tipitini Biodiversity Station multispectral data, this orthomosaic is about 170 gigabyte in size, but now I can actually share this data set in the form of QR code. I'm going to pause here. If you just bring out your smartphone and scan this QR code, then you will be able to see exactly the same data set that I showed you earlier in your smartphone without downloading 170 gigabyte data. It will only stream the data over the region that you're looking at, and you should be able to zoom in, use your finger, and you should be able to see very high resolution drone imagery available right at your fingertips. So I highly recommend you to give it a try. And in order for you to share this data set in our platform, let me go back to this platform over here. Basically, you're going to create a project, and I'm going to show you some of the educational material at the end of this presentation so that you can know how to do this yourself. But for example, this Tipitini Biodiversity Station data, I'm going to scroll down to this project. I'm going to enable this in orthomosaic, and probably this is the one that you're looking at. At the bottom, there is a button called the share. If you just click this share button, by default, it is restricted, meaning that the only person who has an account on this D2S platform and also added to this specific project can see the data. But what I did over here is I open to everyone or anyone. Now I can share this map with others. Essentially what I did is generate a QR code. This is the same QR code that I include in my presentation. You can scan this QR code over here, then you should be able to see it. Or if I like to copy this URL, I'm gonna paste this link in the chat so that everybody can click this link in the chat. Then you should be able to open up this in your browser. So let me just do this quickly. I'm gonna open up the private window. I'm gonna paste the link that I showed you earlier. As you can see over here, I'm not signed in, but I can still just zoom in and see this high resolution images being populated right away. And a good thing about this here is that not only you can share your multispectral data or any form of a raster data set with everyone else very easily, we can also share the LiDAR data as well. So if you scan this QR code using smartphone, that the 3D point cloud that I showed earlier will show up in your smartphone right away. So I'll pause a little bit so that you can scan this QR code. You can zoom in and out to see, using your fingers to turn around, using two fingers in a pinch, zoom in and out to zoom in and out, and as well. You should be able to see this in the 3D point cloud showing up in your smartphone, right away. And if I just, show you that, same thing that I showed earlier, if I go to this Tiptini project, scroll down to LiDAR, and I just, click this one here. I generate the QR code using these features over here. This is the one that I shared in the link. And if I paste that link in the chat, if you click this link that I'm sharing in the chat right now, let me just do the same thing here, coming back, open up the private window, paste that link, then you can actually zoom in to see this rainforest in Amazon in 3D right away without downloading the tens of gigabytes, sometimes in the hundreds of gigabyte data set anymore. You have an access to this one right away. And some of the, if you have a the powerful the computer with a GPU, then you can increase this in a point budget, and you can see in a very detailed structure of this in a forest in 3D. Then you can just play with it. So coming back to my presentation, so I mentioned that something that you can see for the first time is great. I already demonstrated that you can do this by yourself using this technology. You can be a content creator. You can make your content, geospatial data content. You can enjoy watching it, yourself. But even better is you can actually share this great creation of yours with others very, very easily in the form of a link, or you can create a QR code. This is accessible from any computing environment. I already demonstrated, you visualize this in your smartphone, you can visualize in your tablet, computer, laptop, supercomputer, and whatever that is going to be. But I like to push it one step further. Being able to see is great. Being able to share is great. Even more exciting about this is when you actually analyze these things that you never seen before programmatically. What I mean by this is that this data science platform is designed in a way where everything that you uploaded here in this platform is accessible, not only in this platform, but outside of this complete platform as well. There are many different ways of doing it. What I'm going to demonstrate here is that we also publish our QGIS plugin, where you can access pretty much everything that I showed you earlier inside the QGIS. So let me just do that quickly. Going to QGIS, if you go to plugin and manage a plugin here, then I can search for data to science. We publish this in a data to science browser in this QGIS plugin. I already installed it, so you don't have to. I mean, I'm not going to reinstall again, but for those of you who haven't installed it, just click install. We'll get this plugin installed. Once you have this one, then we have this data to science browser installed on your computer. Let me grab my password real quick. Give me a second, because you'll need your password to log in to this system programmatically. So I'm copying my password and type in the server URL, which is ps2.dtress.org, and your email. And I'm going to paste that email over here. Then I'm logging into this data science ecosystem programmatically now. You have all project that you have an access to becomes available over here. So let me show you the Tiptini data set that I was showing you earlier. Let me see, where is Tiptini? Okay. Devastation here. If I choose, then I'm going to choose multispectral, choose an ortho as selected map. And now we are streaming this data over the network. So this is about 170 gigabyte that I mentioned earlier. So it's not going to be as responsive as you have filed in locally, but you can see that it just pops up pretty quickly. Now I can just zoom into this area. So now what is happening is that they are streaming the data set over the region that you're looking at the resolution that is needed to display. So this is the reason why we can actually access this data set a lot quicker than downloading whole data set. Let me just zoom in even further so that you can see the resolution of data set that we are dealing with. And we can just access this data set very, very quickly. Once you have this data set, it just works same as the GOT file that is in your local machine. You can clip into your local machine to any geoprocessing further, and you can just do different colorization as well. So it is almost same as the file is exist in your local machine. Another route to consume this data set is there is a website called pi.d2s.org. We developed a Python module for this ecosystem where you can programmatically access all the data in data science ecosystem inside the Python environment. So all you need to do is pip install d2spy. And we have a couple of examples. If you go to the guide, we already developed some example over here. But the one good thing about this is that we also have Jupyter Hub, deployed in our Purdue data center, where we can actually stream this data set from the data to science instance to this Jupyter notebook extremely fast because they're in the same network. So this is one example that I'm just demonstrating over here that I'm loading all this map. I'm going to just execute this in a code right now, and connecting to the data science instance programmatically. Said, hey, give me all the projects. Then from here, I'm just getting the centroid of x and y coordinate and putting the pandas data plane, and checking that the x, y coordinate over here. Then simply using lip map to display all those the project location on the map. So I demonstrated a way to create this front end screen that I showed earlier from here. So you see this in the screen over here. I created this same result inside a Python environment, but I'm just showing you a very simple example. But you can pull all those the drawn data set programmatically, point cloud drawing programmatically. Then you can just do further analysis using Python environment, etc. So coming back here, I do mention about this open nature of this ecosystem where you can expand your data set to work with any other computing environment out there. We have many other examples where how we can mix up data set from data to science with other database or Google Earth engines, or the National Geospatial data set like in a 3D LiDAR or in a nape imagery, etc. And I have so many the examples out there how to integrate this other open source library like in a LeapMap, GMap, Google Earth engines to be integrated into our ecosystem as well. And the good thing about this is that this is modular, where some of the part that you don't like, that you can develop your own processing pipeline and mix that up so that you can customize whatever part that you like to do. And let me just come back here. Give me a second. And here I'm going to play a video that we generated to highlight what is data to science. So we'll watch this video together.
Uncrewed aerial systems, or UASs, commonly known as drones, are essential research tools for scientists gathering data across various academic fields. But UAS data files can be large and difficult to manage. That's where D2S comes in. Supported by Purdue's Institute for Digital Forestry, the Data to Science, or D2S platform, was initially created for forest environments. Now, it's a one-stop open-source web platform designed to make managing and visualizing any UAS data easy and efficient. With D2S, sharing large UAS datasets is as easy as clicking a share button and sending a link. There's no need to download data. Only stream what you need. Data to Science is constantly expanding its capabilities to work with a variety of other data tools. Users can also publish their data to a public repository where it can be accessed by anyone and become part of a diverse collection of open geospatial datasets. The D2S platform is just one example of how Purdue's Institute for Digital Forestry leverages multidisciplinary expertise and digital technology to better manage and care for forests. Visit d2s.org for more information.
Okay. Let's go to the next slide. So I'd like to conclude my presentation by saying this analogy that I made earlier. when it comes to video, let's say you create a video content, I mean, at least for me, I never think about anywhere else. Go to YouTube, make it available in the right way, for myself, but anyone else who would like to see this, video content. It is so convenient platform where I just upload it there. I know it will exist there. I can easily share with others. I can have, there's a tons of an API out there. I can programmatically access these videos to some, crazy stuff out there. Now, let's say you become a geospatial data content creator. Which platform that you're gonna go upload this data to? I hope that now you're gonna think of this data to science platform as a place for you to upload this data and enjoy yourself and share with others and doing so much crazy innovative the application development that you can do. I'd like to acknowledge all the funding sources. Like I mentioned earlier, this is largely funded by Purdue University College of Agriculture Plant Science 2.0 initiative, but there are other the federally funded support to make this happen. Mentioning some of the USDA project and also NICF project to make this happen as well. And also I did mention that in the video that the Purdue Digital Forestry Institute is another big support of this project. And I'd like to highlight that some of the team members contributing this project. Myself is already mentioned, and Ben and Minyoung is mentioned in the beginning of the video, the presentation. I'd like to acknowledge Dr. Cheryl Ken. She is actually right now Associate Dean of, and also I think a department head in the School of Art here at Purdue. And she's a UI UX design expert, and we closely work with this group to do the UI UX design. And we also collaborate with Purdue Egg IT led by Jared Doucette and Benny Goller and Nathan Denny. And a lot of the IT related support is done by this Egg IT group, and also Purdue Engineering Computing Network staff members as well. And lastly, please visit this website, digitous.org. This website has pretty much all the information about documentation, training, workshop video recordings, information about the QGIS plugin, information about the Python modules, and etc. And with this, I would be more than happy to answer any question you might have.
So, Jinha, thanks so much for presenting this to us. There's several takeaways that I personally had. I think it's always useful to take a look at where we've been and where we are. And I remember, I'm sure many of those on the call do as well, the Blockbuster video days. And I most definitely remember driving the hard drives all over the state of Indiana and beyond. Half the time you show up and the drives are corrupted or something horrible like that. So having moved beyond those days is fantastic. I think one of the big takeaways for this is a resource that has been developed through research dollars that's available in the public domain. It's just here. This particular webinar series that this was presented under is our community resilience series. And I know many times people tend to think about resilience in the form of natural disasters, floods, earthquakes, and tornadoes and things of that like. But when we talk about resilience, we're talking about a whole world resilience. So it's a perfectly natural thing to think about the many applications to unmanned aerial systems, regardless of the name, the technology that you use, and how it can be used to support resilience, whether it is immediate post-disaster, whether it's something more of a long-term nature, such as analyzing and understanding the chemical composition of vegetation, right? So there's a lot here potentially. There is a question that I know that one person asked, and I encourage anyone else on the call to also post your questions. This one was, in terms of the technology stack that supports D2S, is it hosted on premises at Purdue, or is it by a cloud provider?
So
Touched with that.
Yeah, thank you, Kevin, for sharing the question. So to answer is that this instance that I'm demonstrating here is deployed in Purdue Data Center, but can be deployed in any other computing environment as well. So we have actually multiple instances that utilize this data science technology to manage their own data set. This can be deployed in any public service provider like in AWS, Google Cloud, because then everything is in open source, like I mentioned earlier. We also provide Docker images as well. So it's going to be relatively easy for you to deploy your own if you want to do so. But that requires quite complicated setup. So if you would like to do some production like level deployment, you will require some serious computing resources to do so, plus some technical background to deploy it properly. But there are some training video that we did last year where you can deploy this data science to your laptop if you want. But to do that, it is just in a couple lines of code. I mean, the command line where you can deploy right away.
Do you anticipate this being a resource for dominantly public domain resources, public domain data sets, or do you envision, I know a lot of people that work in the resilience and emergency management, disaster response, and all things related fields deal with some sensitive data. Do you anticipate the ultimate purpose of this being for public domain resources, and what's the plan long term for sustaining this if people post their information to it?
So my vision for this platform is, I want to build something like YouTube, like I mentioned earlier, where the user of this platform don't have to pay, where they can use these resources, to contribute this data set. But the one thing that I also like to highlight here is that, once you upload the data, this data is yours, where you have a full control. And when you upload the YouTube video, then you have full control. You can decide whether to make it private, you can make it unlisted, you can make it available to the public so that anybody can watch it. So I'm trying to build almost similar system like this, but specifically designed for this geospatial data, where you can decide whether to make it private, which I already showed you earlier. Once you upload the data, it is in a private by default. So it's going to be secure by default. But you can open up to anyone. You can share this link, which is pretty much the same as an unlisted mode on YouTube, where you can not, anybody can search your data set. But once you share the link, others can actually consume this data set with unlimited access. And you can also publish into the, the public. I didn't cover this one over here, but I'm hoping that you can still see my screen here. There is a stack instance that we deployed in this data science where we have a pipeline where you can publish your whole project to this stack. Then now this becomes the same as in a public video on YouTube where anybody can come, they can do query, hey, give me the data set over this location or this time window. And anybody can find this data set. Now they can stream this information to whatever the pipeline they'd like to do.
I know this is it's in a public production environment at this point, but I know at least I believe it's true that this is also still continuing research, and I suspect, correct me if I'm wrong, that you would entertain and probably embrace input, ideas, suggestions from people on this call and others who might be interested.
Yes, please. So like I mentioned earlier, right now, we don't charge anybody any money to use it open to public. Like I mentioned earlier, you can come to this website, simply click this sign up and put your name, email, and password. Then you will get the email confirmation to check, make sure that this email, email is a legit email address. Also, this email address will be used to retrieve your password if you forget in the future. And we will approve your account, and as soon as it just comes in, then you can just start using it right away.
I would to get some conversation, maybe going for a couple of minutes, I would be very interested if anybody wants to post in the chat ideas for how you can see a platform like this benefiting the geospatial community, especially in the areas of community resilience.
And I see that, sorry, but I see the question in this Q&A section. I'm eager to respond, so let me just answer.
Yes, please do. Actually, I missed that. I was on the wrong tab. There's lots of questions in here.
Yeah, is it just drone data or any geospatial? The quick answer to it is in any geospatial data. So like I mentioned earlier, let me just log in over here. I have shown you the drone data set as an example, but as long as it's geospatial data being, the raster point, vector, you can just, upload it over here, then it becomes accessible. And some of the example that I can show you here, for example, if I go to demo, this is a data layer that we actually developed using 3D LiDAR and NAV imagery, where you can just start to zoom in and you'll start to see that the actual, the building footprint and vegetation layer being populated so that we can see actual height of the building with different color over here and the height of the trees and over there. And we have this example, available over here. And we also go to the Cook County demo. So let me give you a second. This is in the Chicago region that we did. Let me just zoom into certain region where we can see, again, all this data set, we just process, have our own pipeline to generate this layer. Then we just streaming, uploading this layer to this data to science platform that we developed in a web application based on this. Wow, it's kind of slow. Let me just, wow, is there a lot of people accessing it? Probably.
Probably about 80 right now.
I'm kind of, I hope that I'm not crashing this server, but for those of you, you can just, go over here and you should be able to zoom in and see the, very detailed information and, available over there. So to answer your question, it's not just about drone data, any type of geospatial data set is going to work. And Kevin, can I go through the, all the questions?
Yes, please go right straight down it.
So aside from Ecuador data that we examined, what project do you recommend we explore flying around D2S resources? Because whatever the data you have, just play with it. And I only demonstrated this Ecuador data set, but we have plenty of other resources. I think server is going crazy right now, but let me see what I can do. I haven't thought about what to show. Let me show you the Gold Coast data. So this is one of the data that we collected near Cleveland, Ohio. And we have actually, the point cloud data set generated out of this data. And you can see the quality of, 3D point clouds generated from this, drone, where you can see, very, very detailed 3D model of, urban area, where you can see this, buildings in detail in 3D. You can see the cars and all this kind of stuff. So I'm going to say that there's no limit. Use your imagination. I think there's a lot of innovative or crazy ideas that you can implement using this platform. Next question, are there information extracting tools in the platform such as those using the ML and AI and ML learning? Like I mentioned earlier, we do support this in a Python environment. Most of the, the AI, development is happening in Python, so this is in a great place to be. And I'm not showing you all the example, but I have a ton of other Jupyter Notebook example we can do AI training. If I go back to this Tipitini example that I was showing earlier, just show you this multispectral data. Come on over here. That one of my grad students actually trained the AI model to detect all the palm trees around certain locations. So let me just zoom in. And as you can see, they detected all the palm trees, put the bounding box on it. So if I click this one here, they just even give the species name on it. So this is in Eritrea. If I click this one here, this is, coppers. Let me just click this other one here. This is Astercarium. So this in an AI model can be trained so that the difference between the other way of doing it is that now you have to worry about, where to find all the data. Now, I showed you the programmatic way of accessing this data set, so now we don't have to worry about how I'm going to structure my data set. You can actually write the Python script to to pull the data set that is needed on this ecosystem. Okay, Tim Nolan asked a question about can others contribute to D2S platform for shared use? Of course, yes, quick answer is yes. You can contribute your content. You can contribute your the code. We do have a GitHub repo. So if you go to d2s.org, then if you go to, do we have a GitHub repo here? Or maybe documentation page, getting started. Kind of data to science. Or if it is not, I think github.com, GDS lab, and data to science. This is in the GitHub repo. You can just the clone it. If you do any modification, we have whole the documentation about how to deploy yours. and that there is the issues that you can report any bug that you might find, or if any modification you made, you can send a pull request to us so that we can implement those. Okay. Can we feed all the disappearing sources that are quickly becoming move to D2S? So like I said earlier, if there is any use, please feel free to contribute this data. There is no limitation at this moment. I've been asking ask this question a lot. How much data set I can upload to? My question is that please go ahead and give it a try as much as you can. I cannot guarantee that this service will remain free for the rest of your life, but that this goes to true for the pretty much any other web services out there. But the vision here is that I like to maintain this as a kind of free of service to the users by securing federal funding the grant to keep doing this kind of report, but also coming up with other business model where we are not going to be asking users to pay the money, but the other data consumer might willing to pay the cost in the future. Anonymous attendee, if I had the data, I would not want public. I would be able to upload it unlisted D2S without having stored number. That is correct. So like I mentioned earlier, any data set uploaded to data science is private by default. So once you upload it, it's going to be private. It remains private until you just share this project with a specific member in the system or open to public. Link for training on YouTube was mentioned in earlier. This is going to this D2S website. And if you come here, there is a link says workshop, and we've been doing a lot of in-person workshop, and trying to record them. And all of those recorded workshop is available over here. Most of these videos are hours long. Sometimes the longest one is 4 hours long. So maybe you can just watch this video. We start from the very, very basic, how to create an account, how to create a project, how to upload the data, with a different level of the advances over there. So please feel free to watch this training video, and consider contributing your data, and consider open up this data set to others so that the others can enjoy your creation as well.
Lindsay, I think you just perfectly summarized up what I was going to say as well. Yes, you are indeed a very engaging storyteller, Jen Ha. I'm full disclosure, I've seen this presentation before, and it was actually even better this time around. So yeah, we do appreciate this. Working at an academic institution myself, I'm always a big fan of really emphasizing the collaboration that can exist between academic research, academic teaching, and the practitioner world. This is a perfect example where research is leading to something very practical, very actionable, and I can't emphasize enough, it's not a one-way communication. Jen Ha's expressed interest in having your ideas, your feedback. I don't know of any really great academic researchers who would not say the same thing. So take advantage of that. Jen Ha, I don't know whether you put your name and email in the chat, but please do.
Sure,
And
I will.
I have suspicion that you will be hearing some folks. So we are 1 minute exactly from our designated time. That was planning at its finest, I guess. Thanks again for spending an hour with us. And this presentation was recorded. If you think it would be of interest to others, I'm sure many of us can say that's the case, then please let them know about the great type of presentations that we have here at the GPN. And speakers like Jen Ha, always hard to beat when I hear you present, but we do our best. And again, thank you so much for your collaboration with us today.
Thank you for the great opportunity.
You bet.